science presentation in cosmic geometry. On the Nepenthe webcam, this is the Big Sur coast. Something else you can look at, this is on the Olympic Peninsula, about due west of Seattle. I typically will turn this on every morning and go through this, and this, and this. Oh, and you can see that there is some action here. It's dawn for the ISS. Now, what we're going to be studying today, I have been giving a series of presentations on this. The Boscovich force curve was something that was invented by a man named Ruđer Josip Boscovich in the 18th century. Between 1740 and 1770, he did most of his work. He was an astronomer. He was the foremost physicist in Europe, and almost certainly the foremost mathematician. He was a teacher of mathematics. He was actually employed by the Roman Catholic Church as a Jesuit priest, so he was a man of the cloth, you could say, but not at a very favorable time, because the Jesuits were coming into disrepute, and in fact they were disbanded while Roger was a Jesuit priest, and so he ended up moving to France. One of the most amazing scientists of all time. He basically came of age just after Leibniz and Newton had died. So that curve that I've been showing you is the lower one. And you can see it's a multiple curve. The one above it, the top diagram, is a graph of the strong force, which, as you're probably aware, is a proton-proton relationship. Now, that is not Roger's curve. What I'm attempting to show is an inner curve. I'm going to attempt to point at it. It's not this one, or this one, or this one, but it's this one where it begins near the bottom and then shoots up. And you can see that that is an asymptotic line. That is actually the whole point, is to understand asymptosis, which is a very specific mathematical and geometric relationship between two lines, both of which you must understand are representative of something physical. Now, the upper diagram, you can see also has a dip and then skyrockets. That's what I wanted to point out, so I'm going to start there and wrap this up swiftly so we can move forward. Because there's a lot that I want to say about this force curve. It's extremely explanatory, and it's been noticed. It's being noticed by top-level physicists. It's taking a while because mainstream science does not really want or really need this kind of approach to physics. There are two different forms of science. One of them is technology, and it has nothing to do with the search for truth. A real scientist is looking for understanding. Technology is not seeking that. Now, there's a lot more that could be said psychosociologically or socio-psychologically. I've attempted to address such issues in some of my previous video series, but it's really extraneous to our purpose. It's just necessary to make a statement which you really should accept out the gate without me having to prove it. A scientist can be one of two things. He's either trying to make a living. In other words, he's a professional scientist. This man is simply not seeking understanding. Now, he might be, but it's with a different part of himself. He's trying to make money. And that's what's dominating now. A moment's thought will convince you of that if you've never thought about this. But that's all science is today. It has nothing to do with the search for truth or understanding. Nobody, literally nobody, is trying to do that. But that doesn't mean that the human race has changed. It means something else. So without going into that aspect, we are scientists who are seeking the truth of the universe in order to understand it, whatever it is, whatever it is. It's not necessarily mathematical. But one thing I can definitely tell you, it's definitely geometric. There have been 2 excellent comments within the past 2 days, and I've answered them both. Anybody who leaves a comment is very favorable in my eyes, and I'm never rude. The bottom curve is the Boscovich force curve. You can see that it's a multiple force curve. There are 2 particles that are in relation here. It's the relationship of 2 particles at their closest proximity. What Roger was concerned with was the elasticity of a particle surface or its impenetrability and the nature of continuity. And that question has not gone away. He actually answered it, and he actually answered it correctly at the atomic level. A century before Maxwell discovered electromagnetism, so this is not an electromagnetic relationship. One of the commenters thought that I was referring to electromagnetism here. I can't be, because Roger is not. But I made a mistake in using electromagnetism as an analogy because it's a 2-component idea. And Roger composed a 2-component force system, which has been validated. According to my research, he was absolutely right. I'm not alone in that conclusion. There are men with PhDs who've reached the same conclusion. It's not popular, but it's going to be if I get my way because it's correct. It's actually profound. So that's where we're going. Now, first, to clarify, I'm just going to expand this a little bit so you can see it. The top curve is from Wikipedia, and it refers to a proton-proton binding energy radius. And I've explained it so many times, and I've confused people by doing so. I'm not going to do so again, except to tell you that that's a proton-proton relationship where the blue curved line below the horizontal median line represents repulsive force. Okay, now we're going to do something here, and I hope I do this right. We're going to get rid of that. This is the Boscovich force curve, and the first difference that you have to know is Roger didn't know what a proton or an electron were, but it turns out that the way he constructed his algebraic curve, this is a mathematical curve with a formula, and it represents the relationship. To him, it was between 2 particles, but to us, we know we can be more specific, because ever since the proton and electron were discovered, essentially in this relationship by Niels Bohr, this is the Bohr atom. You're looking at a exact diagram of the Bohr atom. There are footnotes to that, but the reason you see multiple curves is those are equilibria. They're spheric equilibria where an electron can come to rest. Those are called electron shells now. Roger had no way of knowing that that's what he discovered. He did not even know that it was an electron-proton relationship. But what he proved is that between 2 particles, the way he defined them, they could have this relationship which he called a 2-force relationship. And he specifically stated, in all deference to Newton, whom he very much respected, he improved on Newton's formulation. Newton, and that wasn't too difficult because Newton didn't really deal with particles. Now Leibniz did, much more than Newton did. Newton is famous for his mechanics and of course for gravity, his formula for gravity. But he did talk about particle interaction. So this is a diagram of particle interaction that was formulated by the man who stepped into the shoes of Newton, Definitely, there's no question of, nobody denies that. It's really remarkable, this life of Roger Boscovich, in that he was the only scientist, the physicist, who was of the same caliber as Newton and Leibniz and stepped right into their place and was the most respected physicist in Europe. And nobody has ever challenged his ideas, which really was just one main idea, his two-force system for particle mechanics before the particle was even discovered. So quite an extrapolation. And you might guess that he was way off. Well, everyone else was. Leibniz certainly was. Newton, again, didn't really try. And nobody tried any further until Thomson. Check out anytime Hurricane Ridge. I think that's gorgeous. The curve is that of J.J. Thomson. From his book, The Corpuscular Theory of Matter. The orbits have been added, so this actually has been edited. I'm not sure how. But it is a very good diagram, and I'll try to show you why. The continuous zones, which it doesn't state which are the continuous zones, but the continuous zones represent the favored orbits. I just wanted you to see that. Now this is the Boscovich force curve, much simplified. I'm going to turn that off now for just a moment to explain why I was showing the strong force curve, which we have now, we're leaving that behind. It's because it's because of that asymptote. Let me just show that to you on the Boscovich force curve. It's this one right there that's going up and up and up. That's the innermost curve between two particles, according to Boscovich. Okay, now, you can see now, it's a little simpler to see. There is one vertical line here. You can see it on the far left. And the line that comes up, the curved line, that's a continuous line. Much different from a straight line, of course. And we're going to be talking about that because it's physically meaningful. But you can see this labeled C, where the curved line essentially going going right to left. There is a nadir, a lowest point, right about at this level, and then it goes up. Well, it crosses the median line at C. What that means is, in the relationship between two particles, the distance between them is now the distance between the origin, which is labeled 0, you'll see it between B and C, and C. That's the linear distance between the two particles. Now the curved line, where it's now intersecting where that particle is, it shows the force relationship, which is none. Now, according to Boscovich's calculations, the two forces are represented as attractive and repulsive forces. These are spheric directions, either going toward a center or away from a center. Think of the center as one proton. That's at 0, and that's called the inertial frame of reference. Because as you know, two particles, neither one of them is favored. They influence each other. But in order to draw a graph like this, you have to state that one of them is inertial, that is, has no velocity. That's why it's the center of the frame of reference. That's also done on the light cone, and I'll be showing that to you as well. Highly significant that this point has to exist. It has to do with relativity. Now, in just regular space without any mathematical or geometric overlay, two protons repel. So that was the previous diagram. So as they get closer, their repulsive force, it's mutual, increases. So they're really kind of not able to get to each other, but it does depend on velocity. Now, if you freeze one, so you're just looking at the other one, it'll come in and slow down because of repulsive force and then be driven away. If it comes this far, it'll be driven away. If it comes this far and gets very close, it's still slowing down, and it doesn't make it to that equilibrium point at C. I'm confusing the images again, but I think you understand. That in a proton-proton relationship, what's below the median line is repulsive force, because the last arc goes up this way. So that shows infinite attractive force between two protons. And all that diagram meant, the one we were looking at before, is that if two protons get close enough, they bind. That's all that graph meant. What this one shows can be interpreted, and is definitely interpretable, as the relationship between a proton and an electron. And what that means is, on the last curve, where it reaches the bottom, that is not, as it was with the two protons, that is not repulsive force. Where it dips, it's attractive force. So it looks like on the last downward curve, that's maximum attractive force. Where if the electron tries to go any farther, it encounters an infinite repulsive force. So that's the difference between a plus-plus relationship when two positively charged particles, these would be protons, get close enough. They repel. Unless they get close enough, they bind. Well, that's a spheric shell, which on one side is repulsive force, this way. But if it crosses that median line, it becomes attractive force. With an electron, it's the opposite. The electron is driving along... God damn it! The electron is driving along that median line. That's the only space. That's the space is on that line. That's the only space you see. So it's showing the linear separation between the electron and the proton. And so the electron comes in, and then what? It speeds up. That's below the line, attractive. Then it slows down. That's above the line. Then it speeds up, slows down, speeds up, slows down. At any one of those ranges, it could come to equilibrium. That's called an electronic shell of an atom. So this is showing the shell system of the atom. That's quite amazing. Because nobody else would get that until Niels Bohr. Now, the most important aspect of this curve is the innermost curve. And for the last time, I'm going to compare this with the strong force curve that we were looking at before. A much simpler curve. It has no humps. It just shows that two protons repel unless they get close enough that they interpenetrate their spherical boundaries. They interpenetrate their force fields, at which time they merge. And that makes the nucleus of an atom. It actually turns a hydrogen nucleus into a helium nucleus. So that innermost nadir is a tipping point where the electron is accelerating to the nadir. The force is increasingly pulling. The electron is accelerating toward the proton. That's what that means. But when it gets close enough, it encounters what you might call force turbulence, although it's quite geometrically visualizable. It's not turbulence in the sense of it being chaotic. These are definite radial shells, and they're fixed, so they're constant. These are geometric constant shells. The innermost one is by far the most important one, because it's the boundary between the electron and the proton. So if you have one proton, which is what this shows, at the 0 mark is the center of a proton, which is exerting, obviously, 2 forces. So physics has not recognized that fact, and that's going to end our lecture. I wanted you to gain that insight. Physics does not understand the 2-force system. It only understands Newtonian mechanics, which Boscovich disproved. Boscovich erased Newtonian mechanics. Newtonian mechanics is incorrect at the atomic level. At the atomic level. You know what level that is? That's the quantum level. And that's what I'm going to show you in the next presentation. I've done this before, but I don't get too many views. I hope you tune in to see the secrets of the universe unraveled before your eyes, and you will be one of the first scientists ever to know what the quantum is. Absolutely know what the quantum is. Mathematically, geometrically, understandably, visually, and realistically. All the way. The solution to the quantum paradox. Stay tuned. This is Anagalactic, bringing you the secrets of the universe. And I'm sorry about the ISS image, but you can always go there and view it in real time and watch the clouds pass by underneath you when it's daylight. and it's not being maintained on about every, I believe it's every orbit. The ISS camera has to be... Anyway, you will be able to see that. So stay tuned. We'll have the secrets of the universe for you. Physics cannot do this. Physics has lost its way. It's been commandeered by the government. And that's the end of any possibility of understanding from mainline physics. That's why they've been in failure mode for a century. Unable to give real men real answers. That's just the tip of a very, very evil iceberg. We want to get out of that. We want nothing to do with that. We want the answers. A scientist is blueprinted to get the answers to the secrets of the universe. And depending on the man, he's willing to give up a lot to get those answers. That's a real sight. That's a real man. So as one man to another, whatever stage we're at, you or I, we are trying to follow up on a blueprint that was designed and imprinted on humanity before there was a human. That has been proved. We'll be right back. This is Anagalactic. Keep looking up.